Alrighty here. So I think I'm set up streaming everywhere. That's good. I have at least 3 different chats open, so hopefully I can see all the potential chats. And I'm Matt, and I've been working on this Voxel engine, this Minecraft-ish style engine, for about 22 days. We're on day 22. It's an hour a day, maybe. Probably over the span of the last, I don't know, 4 months. Taking kind of a hiatus this summer, so we're gonna get back into it here. I need kind of a refresher, so see. I'll keep the link to this stuff on my little notes. All right, so let's see here. Where are you? Chat. So we're on this project's on GitHub. Just pasted the link in my little notes. Let's see. I was going to make sure that we are all synced up. So I'm on for about an hour. Which is typically about right. So for today's goals, I really think that it's going to be mostly. Oh, come on, source tree. A bit of review on our chunk view. Revisit implementation. All right, let me make sure I'm not cropping too much here. Let's see, 550. Okay. As soon as I ensure that we are synced up here, kind of start diving in. I'm gonna have to get some coffee at some point. It's brewing right now, so. So first, a quick look, kind of where we've come so far in like 22 days. I had a little scratch unit test here. This is going to be kind of where we've gotten so far. So this is generating using 32 by 32 by 32 quote unquote chunk sizes. And we're using kind of a simplex noise function to generate this Minecraft-ish style terrain. And we've got a camera object to kind of navigate us around, which we're controlling with a mouse and keyboard. Your typical like first-person shooter. And so we kind of have this nice base framework implemented. We're looking to kind of expand on this, and one of the things we're looking to do is kind of create something that will dynamically generate these things as I pop like in and out of the world. Because right now we're just generating all of this up front, and it's not actually dynamically creating. And what we want is something that's centered on the player. We want something that's centered on the player and that expands as we move. We're gonna want it to pop chunks in, and we're gonna remove chunks as we move. We also have some optimization where we'll need to. Right now, the chunk walls are all visible if I dive down into this thing. Because they're not visible, we don't need these edges, but we will get into that. That's going to be a future optimization. Also some lighting, and right now we're just using this dirt looking texture. So hey Joshua, how's it going, man? Probably don't need this starting soon text anymore. This thing is being a pain. So let me make sure that I am. Well, I could probably do it from here. Ooh. Character rigs. Good luck with that, man. I'm not much of the animator, unfortunately. In fact, I've always found that I have a desire to jump in and do some of the animation and art digitally and fail on a pretty consistent basis. Team Explorer, that's what I'm doing here. Let's see, so changes. Wow, so this is... So we have a good bit here. I'm going to commit all this. A lot of what we've talked about in the past few days on this project were things like how to basically, how are we going to move forward, like with UI and stuff like that? How are we going to support this stuff? And we've been using this OpenGL CSharp, these OpenGL CSharp bindings, such that we can. And the guy who wrote this had open sourced his project, and he also had a UI platform that went along with it. And we've tried it, and we've run into some problems. And I've been in touch with him, but he sounds just as busy as anyone else these days. So it might be a while before we can really dive into some of the UI. Just gonna put updates for date 21. So I'm gonna make sure we're synced to everything in GitHub, and so let me kind of review some of the stuff that we've been working on. Right now we're working on this. We want to know when we move our position. We want to update how these chunks pop in and out of the world as we move, because we want them to be around us and actually have a paintbrush. Let's see if I love how Visual Studio can open everything now. Yeah, everyone always in the tech industry says, like, we're just shuffling papers. We don't really know what we're doing. That's what I say, at least. So we kind of made like a kind of very rough outline here. Is like, if this is our character, we basically have to we want to prioritize the closest chunk that we're on. We want it to be the highest priority, kind of clearly. And then the ones immediately surrounding us, we want to be high priority. And then we have this kind of lowest priority that's all the way out here. And as we move around, if you think about this from top down, as we move around here, all of these are going to shift. And it's kind of just basically a radius that follows us around, and it tells us, okay, well, this chunk is now way too far outside of our bounds or our view. Let's get rid of it, and we're going to move into we're going to have new low priority that are going to need to probably load. And all of this needs to be prioritized, so we're going to use some type of priority queue or some type of priority loading. And I think we're going to start out with a pretty naive implementation and try to move towards something that's optimized and really fast. That's kind of how I've approached all of this. From the start is, let's implement the naive way. And then let's really talk about how we can optimize down and make it a lot more efficient. Let's see here. So I wrote this test, which I'm not even really sure. Let's see what it's actually telling me here. I think I was trying to figure out a good idea on what dimensions I would want. So I made this comment last time. You can tell I've kind of hacked up a bunch of stuff right here. I made this comment last time, is we really want this. The way that I started writing this class is kind of combining storage and the idea of the view itself. And I guess traditional OOP programming would have you split those two responsibilities up. I'm still not sure that's the best approach here, at least with regard to efficiency. But we basically know how large our chunks, or how much data we're going to have in each movement or each update. So it seems fine to kind of keep these things together and then have this sort of update function that will move new things in and get the old things out. So let's see. Part of what so this is actually retrieving the chunk of the position. So this is basically the chunk that we're on. This is our high priority chunk. And then from there, it looks like we're coming up with a max radius. We're iterating through all of them. So this is also quite tricky because we use this to determine which chunks to load. So these things don't actually exist yet, or they may not actually exist. And that's where things get a little bit tricky, because we can't get information from the chunk objects yet. And let's kind of review here. So a chunk object basically is going to give us this is basically it's a world position, and it has references to blocks. And a block is basically the same thing. It's just a type and a position. And we have a hash code that I'm not sure we're even going to use at this point, because vector 3's hash code is really, I think it's non-existent. But the point here is that a chunk is basically a three-dimensional array of blocks, and a block is just a type like dirt, air, anything that represents a single voxel is going to be, or a Minecraft voxel, whatever that would, whatever type that would be, it's just going to be a single unit. Basically, each one of those individual dirt pieces you saw earlier, I think we used a yeah, right here. It's not very pretty, but we basically created like manually those chunks you saw earlier in the little fly through. Okay, before I continue diving into this thing, I am gonna grab some coffee real fast, or I'm gonna likely fall asleep. Oh yeah, so that's awesome, dude. By the way, yeah, those are the state transitions. That I find those actually insanely helpful. Now I work with Unity every day. Although I am currently mainly a server-side developer, I still will do some client work every now and then. And we're doing a lot of Unity stuff, and it's part of the reason why I'm not into Unity now. I'm sticking with OpenGL and it's kind of some old school stuff, so I don't even risk crossing over or mixing work in the live stream. But do I have a combination of music going on here at once? Sounds like I do. Let's see. Let me see if I can. Trying not to make it too loud here. All right, I'm going to grab a quick cup of coffee. I'll be right back. All right. So, kind of the point of all this is we may or may not have an actual reference to a chunk in this algorithm. So, we can't rely on something. We can't rely on any data that's going to be stored in that chunk to determine whether or not it's in quote unquote view of our position. So, and that should be fine, because we can infer basically on where we are whether or not we should load some chunk that may or may not exist yet. So this is kind of I think I remember. I mean, this has been weeks since I last streamed, so I'm a little fuzzy in terms of where I was, but I do distinctly remember, hey, let's just write out all the variables we have, and then and then let's talk about like how we can use these things and how we can break them down and whether or not we'll even use them, and then we can remove some things. So this was sort of where we were, and one of the things we do right off the bat is we just pass in a radius of this chunk view. So I think for the radius, I think right now we're using like 2. Let me see if I'm actually even creating this thing in here. I'm not. So let's just assume we're using a radius of 2 here. I don't think this is right. This is based on blocks. This adds another row. So we need, what we discussed last time was also whether or not we use block units or whether or not we use chunk units. And I think it really depends. And the one edge case that I constantly, that I've been thinking about this entire time is, let's assume you're right on the border, your character is moving in and out of a chunk that will force load one chunk that's maybe, you know, on the back end of the loading queue. If we move in and out really quickly, you know, it's constantly going to be this sort of like load this, unload this, load this, unload this. And given that right now, and I guess eventually everything will be loaded from the disk. Right now it's all dynamically generated by this very slow terrain generation. It doesn't feel right. And I'm normally not one to optimize early, but it just, something about it just doesn't really sit well with me. So that's the edge case that's kind of irked me a little bit, that that I really want to solve. If we use a higher resolution of position update, in other words, if we use position updates based on a block, we're going to get better details concerning whether or not we should load or unload something. However, it just seems kind of like overkill as well. So I'm not sure exactly where I sit on that currently, but I will say this, that it does feel like using the chunk coordinates, which are basically increments of 32 units. It does feel like using chunk coordinates is going to be a little bit easier on us. I don't think I need a center either. So in that case, we wouldn't even need a center. But for our chunks, I think what we really wanted was, we want this diameter to encompass basically all of the potentially loaded chunks. And then what we'll do is we'll prioritize those based on their distance from position, if that makes sense. That's how we'll just do a naive sort. And we'll pass in some sorting parameters, and that the sorting parameter will basically be a distance function. So +1. I think that's kind of generally what we use. We used radius times 2 plus 1. So if we're passing in 2, we're gonna get 5. We're gonna get 5 chunks. So if you think about, and my math isn't always on point in the mornings, but and I don't actually have a calculator button on my keyboard. Let's see, 32 times 5 is 160. So that's 160 blocks. Well, that doesn't seem like a lot. However, let's see how many of these init chunks. I think we're just making, I think in the demo that we'll look at it again just to kind of get an idea. So what is it? What is the Josh? What is the name of the animation? Sorry, I didn't mean to cut that whole topic off. We could talk about Unity as much as we want, but a lot of people have asked me, "Hey, C#, why not Unity?" And that's just I was basically preemptively answering a question that you never asked, but I felt it coming. So I just went ahead and specified, but we could totally talk about Unity. It's not a thing. In fact, I encourage it to discuss pretty much anything related to programming or graphics. What is the name of the animation rigging system? It's like Mecha something. I'm horrible with these tech names. That music got a little bit louder. Yes. Do you overall enjoy it? I've found that it's pretty sweet. I mean, clearly from looking at your dependency diagram or your state transition diagrams, it can look a little bit crazy at times. But I like, from what I've seen, it looks like it's one of those things that's just like incredible in terms of how it helps like basically just take any sort of like rigged animation and just toss it into Unity and then have those things smoothly interpolate from one to the other. Sounds like a lot of work you could avoid and just let Unity do it, which Unity does that sort of thing really well. So, all right. So I kind of mentioned what we're going to do is try to avoid, like, I kind of scratched down basically, all right, we could do it this way. And then I just started writing code, and it's not always the best approach, but it's kind of how I went about it. So we were looking at diameter here, and I was trying to figure out what 160 blocks. So this is a 3x3. We're creating a 3x3 section here. So let's look at this again. So this is going to be 96. No, yeah, 96. So we just said 160 would have been our diameter. So this is basically outlining, if we're in the middle, then we can see. Yeah. Let me run this, because this will give a really good. And I also think that it brings to light one of the. Okay, so if I'm standing here, basically, I mean, that seems really good actually. So basically, if I'm standing right here, I'm looking out into, basically if I'm looking straight down this line, that is 96 blocks. And so that's about what we would see. But instead of just seeing these, like anywhere we turned, we'd have this on all sides of us. So for me, I guess that seems like it's a pretty good distance. I still feel like if you like jump into Minecraft, I still feel like if I flew way up here, I could see much further out. And so in that regard, it seems like maybe it's not large enough. But right now, I mean, this thing it generates slow, but it renders quickly. Like, we're at 64 frames a second. You can see my little frame rate ticker happening. Let's make this a little larger and see kind of. I wonder. let's start with a negative here. I think that's, I don't know why I have a uint. Unless, oh, you know what? I think that we're going to be bound to positive integers. I'm kicking myself now for doing that. So we'll do less than 6, and then possibly we can throw our character or our camera position kind of in the middle of pardon my silence for a second while I attempt to process some of this. Sir, mouse movement, window creation. God, this is we've noted a couple times that this is scratch code. This is not like here we go, main camera. We moved -10. I think we can move to like 48. Let's move to like 48, 32, 48. Something like this. Oh, that's pretty awesome. Oh, how's it going? So I've thought about, and in certain cases I've started writing, but I never made it much further than just like a prototype. How's it going, Joe Mega? For anyone watching on YouTube or watch me work, just kind of filling you guys in. I'm not talking to myself. I'm restreaming to Twitch as well, and I'm chatting with both. So. Did I lose the Watch Me Work stream? I think somehow I lost the Watch Me Work stream. Let me see if I can get that back. Let me see if I can get this back. I don't know why. It says I'm next in line to be paired. I'm not really sure. I think I lost. It was kind of in and out, in and out. It says I'm next in line to be paired. That's really odd. I guess I have to have that window open. Anyways. Well. It says I'm next in line to be paired. I guess there is a pairing that has to happen. Yeah, I guess. Right now I'm literally just running like a YouTube programming mix playlist. But I don't have my bot up that actually will just accept friend requests. Will accept song requests. So, yeah, anything I would have to do is manual. I would just hold off on it right now because, yeah, I need to get all that set up again to. Oh, that's interesting. So, Josh, hang out, man. In this, whenever we do the stream, I am so curious to know, if Photon is scalable or is worthwhile. I honestly have never heard anything Hey, look, I'll swap it out here. Originally, when I envisioned this, all I thought about was, okay, we'll just call like, hey, update, and it'll just it'll move things in and out. However, it needs to be, I think whatever it is calling update should be aware of what is being added and what is being removed. Because it clearly will need to know that it needs to load these things. So I'm thinking maybe a better approach to this is not an update, but more or less a, hey, give me a list of dirty or updated or changed chunks, where a change can be defined as I've been updated, I have a different block that's part of my chunk now, or I've gone from non-existent to existent, and also from existent to non-existent. I think that is really what I want. Naive approach to this is to basically have, okay, here's our updated list and here's our old updated list, and compare the two, or run it like, that's disgusting, to be honest. I hate that solution. Even the naive approach is, I don't even like where that logic. Believe it or not, I've already put a substantial amount of time thinking about this problem, and it's still, when I sit down to write it, it's still one of those things that I just feel uneasy about all the time. I'm trying to write something like this, because it seems very straightforward, but then as you start writing it, it just kind of falls apart. Change. Yes, I want to see the potential fixes. Like, why? Come on. So let's. Who knows? It's whatever YouTube decide to play next. Here, we'll go back to this. This background noise, basically. So let's see. So I prototyped something. I just have to figure out where I put it. Come on, Windows. Hello. Yeah. So yeah. Anyway, we lost the stream on Watch Me Work for a little bit, and I think we're back now. We're basically at our time limit anyway, I think, or at least our featured time slot. But that's fine because we can keep going. And I'll probably go for another 30 minutes or so. I haven't really accomplished a whole lot today, unfortunately. Especially been me wrestling with trying to get back up to par with figuring out where I last left off. I think I have something called proximity. So I wrote some notes like 2 weeks ago before I left to go on vacation. And okay. So we actually do it this way. We will have two we'll have an update and we'll have a get dirty coordinate. Okay, so we'll bring back our. I think we had a. Yeah, we did. We had a center. So let's bring this back. I don't know how relevant it's going to be, but let's bring it back and let's say for right now it's just going to be the origin for right now. And what we'll do is we'll update this based on position. So our position. Something Z. And really what we'll probably just end up doing is merging these, but for right now, that's fine. We don't care about diameter. We don't need that. Actually, just go ahead and max radius. Just making sure, let me think about this. So we need to basically iterate through all possible, our entire size of this three-dimensional array here. And we just need to translate this to an actual chunk position, which we can do by just multiplying by the dimensions. So we'll try to accomplish this first, and then we'll look at the get dirty, because I think that's going to be a little bit more of, it's going to be slightly more difficult, maybe. Also, we don't, main chunks, and we'll just call this swap chunks. And the reason why I'm doing this is because we're faced with kind of a decision here, which is, we can't modify, well, our we create this new guy. What I'm trying to think is, like, can I modify the same list, or can I have, basically, do I need to have like some sort of swap list where I create the deltas, and then, or where I create the updated version and then I swap it out. I was leaning towards having to swap it. We're basically taking what we know to be our radius here. This is going to be our entire, from start to end, is going to be our entire X and Y and Z, basically our range. And we need to fit that range into 0 to view width, 0 to view height, which is literally just an offset. So that's not the difficult part. What I'm trying to think about now is so right off the bat, we're like, I'm just first iteration through, first update that we do is not going to be, it's not going to be anything. Essentially, we're gonna run through this view depth or whatever, and we're just essentially gonna say, yeah. So basically, we're just gonna check to see. Okay, so we'll just say if null 90. Let's write some code. God, I haven't written a single line in this entire hour and a half I've been staring at this. Basically, if we have a null chunk here, which we're going to, this is at the very beginning of this, the first update we do, we're gonna have a null chunk, and basically, if it's non-null, then we need to get the world position. And then from that world position, I guess it's as simple as we need to check basically if it's in our range, right? So let's see. So it's probably going to be better to figure out a let's make a little, this is what we'll do. We'll do a bool. We'll do in view, and we'll pass it a vector3. And this will, I think, be as simple as this is why I had these. Max visible will be a new vector3 and radius +1. Nukete basically our max visible from all sides, or maybe this should be our diameter. Oh yeah. Oh no, this is right. Radius +1. And then we'll say min is going to be our center. Our center is basically going to be our center chunk, and we'll do center minus max visible, and then our max is going to be center plus max visible. That's basically going to give us start X and start Y here. And so I believe that there might be something on vector. We can do that. We can do it the old-fashioned way. We'll do position dot x it's got to be greater than. Yeah, we want to be inclusive. We'll do greater than or equal to min dot x, and position dot x is less than or equal to max dot x. Let's see, and position dot y, min dot y, and position dot y is less than or equal to max dot y. And z greater or equal to okay. So this is just going to give us our whether or not we're in view anymore. We can go ahead and move this since we're not using that variable, those variables anywhere else anymore. So this is where we're just gonna update our center position right here. Then we'll use basically our in view here. Although I do not believe, maybe we are going to need to remove I actually think we are. We're gonna need to remove the bound. We're gonna need to have some sort of remove event. So I'll just go ahead and add this. We'll just do a public event. We'll just do action vector 3. Why isn't it automatically adding these references? It's kind of annoying, to be honest. And we'll just call this on chunk removed. It's fine for now. Dispatch when chunk is moved out of range. So if we're gonna say if not in view, this world position, then really we're just going to be on chunk removed, invoke, and we're going to pass world. And then I think else we need to map it to our oh, okay. So I was right actually initially, because so we'll need a swap. And this will be our little temp. We'll just call it swap. Because the reason why is because things can shift. Basically things can shift around while we're modifying it, and that's not good. So we'll create basically a swap array that we'll use to populate, and then we'll flip them. Because otherwise we would be allocating this thing every single time, and I think that's not okay. So we'll just allocate it right up front. So this is our in view. Actually, we'll just use a continue here maybe. No, it's not. Let's use an if else. Then we'll basically need to translate that world coordinate. Actually, to view coordinate. I guess that's a reasonable method name. So position, and essentially this is what we want. We want to return new vector 3. We want to do the same thing we did with our center, which is this. So I'm just gonna copy this guy. I think we're gonna create two different versions of this. So this is going to be one, and the other one, I think we're going to want to we'll pass a ref vector 3 destination. And then we'll do this destination.x. And so this is gonna let us avoid for our center. It doesn't really make sense to create a new vector 3 every single time we call update, because update methods are, called very frequently. I'm gonna sneeze. Excuse me. So we basically don't want to to be creating a new instance every single time. So we'll just call this guy and we'll pass it position and ref to our center. This is just gonna, it'll just store the updated center there. This one's gonna create a new one, which is fine. Now, this may not actually be. This is going to be our center minus. I think we need to offset this now by the max visible. So at 0, 0, 0, we want this thing to be at our minimum. Basically, we just have to take this thing and figure out where it is relative to the minimum, right? Relative to the minimum. So if I'm at 20, 20, 20, and the minimum is 15, 15, 15. Why is this so difficult to think about? It's making my head hurt. Basically, what we have is we're iterating through the current chunk list. We're getting the coordinates from the old list, or what we believe to be a stale or an old list. We have a new position, so we have basically a new set of potential chunks that are going to be surrounding us. And what we need to do is we're iterating through the old list to see if it's still, basically, if we don't move, this list stays the same. Nothing changes in it. But if we've moved and we've changed, then the positions in which these chunks are located currently, which they're indexed currently, is going to change. The index range for this array is basically like 0 to 6 for all three coordinates. Essentially what we're doing is we're looking at the old chunk world position, which will be like essentially it's increments of 32, so it's like 0, 32, 64, 96, etc. We're getting basically the relative world position, which is going to be just that coordinate, the world coordinate divided by the dimensions of a chunk. So like if I'm at 64, 64, 64, it's the same as the relative coordinate of 2, 2, 2. And then using that relative coordinate, I'm trying to figure out how that fits into the 0 to 6 range, if that makes sense. So I don't think we can assume that we're using X, Y, and Z. I don't think we can use the X, Y, and Z indexes or indices from our loop. So this is gonna translate into our relative coordinates, which would be like just the multiples of 32 or our chunk dimensions, and we're gonna subtract this, our min, and the min is basically taking our, that would have been bad, our updated center position. We probably need a property here for this, but this is basically taking this position gets updated and put into our center. This is giving us our relative. This is giving us this position, world position in relative chunk terms. And then we're subtracting the max visible this radius. Basically it's putting us in the lower left hand corner of the entire render, or the entire chunk, the chunk matrix, or whatever you want to call it. And then so we have this minimum point, and in order to like fit it into this range of values we have here, we offset it by that minimum. So we have this view coordinate for the world position. This is, if we assume 0, 0, 0, right? Then it's going to be, it's going to be in the very back. Well, if we've moved over, then it's going to be gone. It's not going to be in the view anymore. So we execute this. Otherwise, it will become in the view, but it might have shifted an index, or it might have moved somewhere. So this is why we need to account for the swap. And so what we actually do here is offset position let's offset it by that minimum, which is going to take it. So if it's like 1,000, 1,000, 1,000, and our position just assumed is like, I don't know, 1,002 in for all axes, then basically we're looking at like the second thing in each index. So we'd have to subtract the minimum in order to offset it into the range that's going to fit inside our view width, height, and depth. So I think that we have to also check this, because I do believe that if we run up along the negatives, I think that we end up with a scenario where we can all right, Gel Megas, good to see you, man. Take care, brother. We'll say is legal view coordinate vector 3. Return position.x greater than 0 and position.y greater than 0 and greater than equal, and position.z greater than equal 0. Okay. So at this point, we basically moved it in here. I think this is fine for now. And at this point, we'll have a temp. We'll store so this is where things get interesting. So let's have like let's set here. Actually, you know what? let's just do this. We'll just do I enumerable. I think we should do enumerable. Maybe enumerator. What do the actually, let's just return a list currently, and then we will what we'll actually do is end up returning a probably an enumerator, and that way we can hold on 1 second. And that way we can use like a yield return. So let's just return a list right now, and we'll just put we'll have get dirty chunks, and I'll be honest, I don't know if we should do another update. I don't feel like we should. I feel like these should be two different. Yikes. Just a day in the life. Dogs losing their shit every time a squirrel runs up a tree. Hey! Shh. Shh. So essentially what we want to do here now is we want to be able to I don't think we care about our position, but let's actually let's do this. Let's pass in our world position here, and that's going to let us do our sorting. So really what we want here is I think we want like another loop here. So I'm just literally gonna copy and paste this. Want another one of these deep diving nasty nested for loops, but to be fair, it's 6 times 6 times 6 iterations. It's really not that bad. 6 cubed. I think if we use a 2 radius. And so for here, how do we need to do this? We need to offset this. So we'll just grab our chunk. We'll just say chunks at X, Y, and Z. And what we'll do here is if this guy is null, then it needs to be added to our list. I'm going to create a scratch list here. We will probably end up moving this out here so that it's pooled, but for now we'll just create a new one. It's fine. Actually, you know what? No, it's not. Fine. Let's go ahead and do this. I know I said I wasn't going to pre-optimize, but we are. At least until I can... at least until I can switch it to an enumerator. Because really, we don't need a list at all. We can just... So we'll just start out by clearing this each time. So if our chunk is null, then we'll add it. Hey! Can't deal with it. Shh. lets me pass like a copy constructor or something. It doesn't. Of course it doesn't. Wow. .x plus x rel view chord .y equals offset .y plus y. View chord .z equals offset .z plus z. So this is basically offsetting our offset by where we are in this loop. So this is taking the most minimum value we can have based on our center position, and we're iterating through here, and then we're incrementing it, and we're basically adding those increments to the offset each time. And from that we'll do this, where and I think also like we'll add some savings here by doing, we'll add another version where we can pass the reference vector 3 target, our destination. And then from here we can do destination.x equals just a slight optimization, so we're not allocating so much junk every single time we do one of these loops, which is going to be very frequently. And so we'll do from view coordinate, and I think we could do this. Oh, I'm an idiot. We'll call this view coordinate vector 3, and we'll pass it there. So we'll do the from view coordinate, and we'll pass it view coord. And then from here, so this will give us basically our relative to the world coordinate. This is going to be our world coordinate, essentially. I should call it this world. So yeah, the first thing we really wanted to do was if our chunk is null, then we want to add this. We want to add this world coordinate to our list of dirty our dirty chunks. So from here we'll check. So here we want to get, how do we want to do this? We want to determine I think basically from here we would want to do like a chunk, and then we'd want like a is dirty. So we could do like I'm gonna comment this out. This is kind of a future edition. We'll do like if chunk is dirty, and we'll also add it like that or something. I think because I think we aren't expecting this guy to go out of scope. So for our case, this is always going to be let's see if we could sort. This is probably just a quick sort, I believe. Greater than y. So if this is greater than this, then this will be a positive integer. If this is greater than this, then it will be negative, which is the other return. So there you go. A nice little sort. And then we can just return it. So we have our little scratch. We will probably, let's just get rid of it. Well, let's not get rid of it, but let's just remove that because we don't need that test code anymore. But let's create a chunk view. think we can make this slightly easier. I kind of want to visually. Actually, let's just do this. Let's just do this and we'll set a. Okay, so right off the bat. We'll do if rel view chord actually is legal. We're going to check as not. So if it's not a legal view coordinate and we'll pass relative view chord, then we'll just continue. We don't want to add these if they're dirty, or if they go into the negatives. At least for right now, we're not doing that. That's just not the way we're gonna do this. So you're gonna see we got all positive things. We're all right. So let's remove this breakpoint for a second. Let's continue execution. Let's move. I need to make it so if I hold shift, it increments or it runs. No, I don't want sticky keys. Here, I'm gonna add breakpoint again. So you could see as we're moving, basically it's giving me more. Now these are always going to be null. That's why it's giving me 74 or 72 updates. And before, when I was like in the 0, 0 range, it was giving me like 64 updates. But the reason why is because they're always null. We're not actually, once we start generating these things and then storing them back inside the view, then we'll start getting we'll start getting basically lists that aren't as nearly as big. Because if you think about it, we're only going to get pretty much a dirty view if we've if we've changed something, if it needs to be generated or if it needs to be removed. Those are the options. And so this list should be normally fairly small. You do run into some things where, especially when we start looking at updating blocks and changing things, where if you update a block in one chunk, it could very easily have an effect on its neighbor. And then that would basically flag both of them as dirty. And so you can see these kind of propagating events that happen when you do this sort of thing. But I think this is pretty good. I mean, this is when I pictured naive approach. This is exactly what I was talking about. It's basically just brute force iteration. We have some minor optimizations. We're using a swap. We're using a swap for moving things in and out of the view. And we're trying to maximize our reuse of vector3 objects and stuff like that. But in general, this is not too overdone. We have our chunk removed, which we should probably actually check, to be honest. So let's just test that just to see how that works, or if it works. This essentially will just print out anytime we run out of. So as I'm moving, well, there we go. So as I move, you look in that console over there, as I move in and out of things, so I'm gonna write a note here and I'll put a fix me. If chunk does not exist, then on removed will not be called or be dispatched. So this is the problem, is basically assume that we walk somewhere and it says, okay, this chunk is visible now. We start loading it because it would be on the dirty chunks. We start loading it, then we move away from that spot and it is removed from the visible list. We're mid-load. It would be nice if we could just say kill the load in progress. We don't need that anymore. Although kind of that may make sense for right now. However, we probably will at some point want to keep some sort of LRU cache for loaded chunks, and that way it would handle the issue that I was talking about earlier that I didn't like, where we're in and out of a view and the chunks popping in and out. There needs to be some kind of a buffer there, and so that's probably worth investigating a little bit more. And then so this may not be necessary then, but that's the situation in which this addresses. I'm going to bounce for this morning. Thank you guys for tuning in. It's been about a 2-hour session, which is good. I'm going to probably be doing this every Tuesday or something. So anyway, I will see you guys next Tuesday, and thanks again for hanging out, and I'll see you next time.